Today we want to focus on that other type of numeric response question that we're going to see that's a little bit different than the rest of them. Yesterday we talked about that one numeric response question where we have to list the principles we used to solve it. Okay, that's one question. List the principles 0 through 9. We can handle that. In fact, that's a good thing because that question tends to be a little bit easier than the ones that you actually have to solve for something. Now, we will get one of those. The other type of question that we know we're going to see on the exam is a graph. And I've mentioned this to you 100 times. You're going to see this question that is a graph. It may be a graph that you've seen. More likely, it's going to be a graph that you haven't seen before. In either case, that's okay. We know how to deal with it. Today, we're going to review how to deal with that. But before we do that, I want to refresh your memory on one thing that I showed you one day in class, and that is how to plot the graph, how to get the data from the graph on your calculator so that you don't actually have to do a line of best fit by hand and calculate the slope by hand. Through Physics 30, when we do labs, we use, typically at least, Google Sheets to calculate the slope for us. We can't do that on our diploma exam, so we have to have another option unless we want to do it by hand. We don't want to do it by hand. A, because it takes longer, and B, because there's some uncertainty with that line of best fit, right? If you don't draw it perfect, you're not going to get quite the right answer. So I'm going to ask you to take out your calculators, and I'm going to ask you to follow along with the procedure that you have listed on page 11 of that handout that I gave you yesterday for plotting a graph. Okay, here's the table. We've gone through this before, okay, but we're going to go through it once more here today. Here's the table. Okay, it doesn't matter what the variables are. I'll just call them X and Y right now. My data is going to be really, really simple. 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. Now, if you got data like that, okay, you probably wouldn't even need to put it on a calculator because you can tell right away that the slope is 2 and the y-intercept is 0. The bad news is you're probably not going to get a graph on your test that's quite as simple as the data that you see right there. But we're going to use that data just as simplified data to put it into a calculator and see how we could get that slope of 2 and that y-intercept of 0. So follow along with me. Okay, we've done this once before, but I'm going to ask you to follow along with me again. Everybody on their calculator does this. So do this first. We've got to turn on our calculator, I guess, first. And then what I want you to do is hit Stat. Okay, it's this button right here, Stat. Okay, and then you got to hit Edit because you got to enter your data. Remember, Stat is where you always go for your graph. Everything you do off the main screen is Stat. Okay, but then there's a couple of options from there. The first one is Edit. That's what you got to do first because you've got to enter your table. Now, I don't have anything in my table here. Okay, it's blank. If it wasn't blank, let's say I had 9, 6, 3, whatever, and I didn't want those in there because I wanted new data in there. What I'm going to do is just scroll up and then literally hit Delete, Delete, Delete. Now I got a blank data table again. Okay? I think when your calculator is cleared for your diploma exam, it will clear that as well. So I don't think you're going to have to do that in your diploma exam, delete a whole bunch of data. Okay? But you know how to do it if you do. All right, let's enter the data. The first column was 1, 2, 3, 4, 5. The second column we had was 2, 4, 6, 8, 10. That's it. There's my data table. That was pretty simple, eh? Pretty easy. Now what we're going to do is go to Stat again. Okay, so let's hit Stat. Okay, we're at step 5 right now. Stat. But this time, instead of editing, we don't need to edit because we've already entered our data table. We're going to calculate this time. So it's going to be Calc. And then it's going to be option 4, which stands for linear regression. Hit Enter. And then you're going to hit Enter again. And that's going to spit out the slope in the form of y equals ax plus b. We call it mx plus b. They call it ax plus b. That doesn't matter. The slope of this would be 2, and the y-intercept would be 0. Does that make sense? The data that we had was really easy to determine the slope and the y-intercept anyways. Okay, but now we can see that we were right. The slope was 2, and the y-intercept was 0. when we get a graph that has crazy data, or normal data, really is what I should say, where the first x point is 6.21, and the second x point is 9.34, and so on, right? Different numbers like that. It becomes a lot easier to do it this way, okay, than it does by hand. Any questions about that? Okay, we'll take a look at that again in a couple minutes with an example, okay, a real example. In fact, a question that actually did appear on a diploma exam a couple years ago, okay? But before we do that, what I want to do is refresh your memory as to how we actually do the analysis of a graph, the whole y equals mx plus b thing. We've got a number of examples here, okay? What I want to do is take a look at, let's go with one example, and I think that's the first example. Yeah, page 2. We got a graph here of EP versus H. EP versus H. All the solutions are listed below that, okay, on the sheet that I handed out to you yesterday. But I want to go through that process, okay, right now, real time, just like we have for every activity that we've done this year. Okay, let's say we want to find whatever. Doesn't matter what we want to find about this graph. Okay, how do we analyze this graph regardless of what we want to find? Notice it doesn't even tell you. It doesn't even ask you a question here. It just says, here's the graph. That's the strategy we almost have to follow when we see a graph that we've never seen before, right? Is just analyze it. Go about the analysis without that idea of, oh, I got to find this. I got to find the value of G, or I got to find the value of M, or whatever the case may be. Just analyze it the way you know how to analyze it. Now, the good news is the graph you're going to get is almost certainly going to be a straight line graph. A straight line graph always has the equation y equals mx plus b. Okay, there's your equation for every straight line graph. Now, what do we do from that? We replace y always with whatever appears on the y-axis. That's going to be EP. We replace x with whatever appears on the x-axis, which in this case is going to be h. We replace m with slope. Typically, the y-intercept will be 0, and we can drop that. But we'll deal with that in just a second, okay? The next thing we do is find an equation, usually from our data sheet, but occasionally a derived equation that has the same two variables in it. Okay, what equation has EP and H in it? Without looking at your sheet right now, what equation is EP and H? Simon, it looked like you were ready to raise your hand, were you? No? Okay, do you know it? Okay, what is it? Good. So from our equation sheet, or from a derived equation, we would say EP is equal to mgh. Now, let's cross off things that appear in both. EP appears in both. H appears in both. We're left with the slope is equal to mg. By the way, why did I cross off the y-intercept? Well, A, because the line pretty much goes through the origin. B, because this other equation from our equation sheet doesn't have a plus something, right? So we know that there shouldn't be a y-intercept there. If it was mgh plus something, then there would have been a y-intercept. If it's just mgh, then there is no y-intercept. All right, so the slope here is equal to gh. You know how to get the slope. Do it from your calculator, right? If you've got the, no, sorry, not gh, should be what? Slope should be equal to m times g, right? If you've got the value of m, then you can solve for the value of g. So maybe this question was, what's the value of the gravitational field strength? Or maybe they give you the gravitational field strength and you're asking you for the value of mass. So you get this graph and they say, what's the mass of the object? Or you get this graph and they say, what's the gravitational field strength experienced by the object? Okay, and at first you're like, what? How am I possibly going to get this from this graph that I've never seen before? Follow the strategy that we always follow. Y equals mx plus b for the graph. Get your equation from the equation sheet that has the same two variables in it, and then figure out what the slope means. And if there is a y-intercept, figure out what the y-intercept means. Okay? Let's try another one here. This one's a little bit different, because this one has not a linear variable on the bottom, but rather t squared on the bottom. D versus t squared. But it's a straight line. If you plotted d versus t, it would actually be this shape. The way that we straighten that is to plot d versus t squared. So basically, if we had d versus t, we'd take all the values of t, square them, and when we did that, we'd get a straight line that looks like this. Okay, that's the graph that we're actually going to analyze, is the d versus t squared, because it is a straight line. All right, go through the procedure. First of all, get your equation from the graph. What's always the starting point for the equation from the graph? Bo, what's the first equation that we write down? Always. Good. Y equals mx plus b. What's the next step? What are we going to do now? Kirsten, what's next? What's next, Devin? Before that, we got to do something with y equals mx plus b first. Yep. Good. Good. We got to put in what the x and the y is. Now, y is d. M is the slope. And we're always going to write that word slope in there to get rid of m, because we don't want to get that m mixed up with mass. M has two different meanings, right? Mass and slope. And we don't want to get it confused. In this case, there is no mass in here, so it probably would have been okay. But sometimes mass appears. We don't want to get that mixed up. Okay, the x-axis would be t squared. Okay, y-intercept kind of looks like it goes through the origin here, but we'll deal with that in a second, okay? Now what do we do? Devin said it, I think, a minute ago here. Yeah, not d and t, d and t squared, right? We need d and t squared in that equation. And that's going to come from our equation sheet or from a derived equation or something. Okay? What's the equation that has both d and t squared in it? You got it right in front of you, but hopefully you're not peeking and cheating. Okay, what's that equation? It's a physics 20 equation. You won't see this graph on your test because it's a physics 20 equation, but it's the same idea that you go through here. Tom, what is that equation that we're going to use? Okay, so VIT plus 1/2 AT squared. Okay, you said 1/2 AT squared plus VIT. That's fine. In fact, I'm probably going to want to actually change it to be in that order, even though that's not the way that it appears on the data sheet. This is the way that it appears on the data sheet. I'm going to probably want to do this. D is equal to 1/2 AT squared plus VIT, just to make it look a little bit more like this one, right? Same order and stuff. All right, there is a plus something here, so there is a y-intercept there, right? D is equal to the slope times t squared plus b, right? Okay, now what's next? Cross off things that appear in both. D appears in both. T squared appears in both. All right, the slope is equal to 1/2 a. Oh, y-intercept, b, what's that? The y-intercept is equal to VIT. So depending upon what you're given, Caitlin, please. Depending upon what you're given outside of this graph, just as separate given, here's the mass, here's the initial speed, so on and so on and so on. You could solve for any one of a number of things here, including the acceleration, including the initial speed, including the time, whatever the case may be. Wouldn't be time, I guess. Right? Yep. Well, it doesn't really matter. Okay, in the end, if we had left it as, okay, the question, if you didn't hear, guys, was how do we know to swap that around to put VIT at the end? Okay, and my answer is it doesn't really matter. It's just a little bit easier to visualize if you do that. Okay, we can look at this and say, all right, let's cross off things that appear in both. D appears in both. T squared appears in both. Okay, what are we left with? Slope is equal to 1/2 a. How do we know that it's the second term instead of the first term? Well, because that's where the t squared is. Okay, I wanted to change it around just so it was all in the same order. I just find it easier to see there. But if you've got VIT plus 1/2 AT squared, blank squared plus, it doesn't really matter. It's just a little bit easier to visualize, I think, if it's in the same order. That's not too bad, eh? Okay, this is one. Hey, we did this one for an activity, actually. Sine theta 2 versus sine theta 1. Remember that one? The Index of Refraction Lab? We've done this one. This is one that I wanted to do. This is the last activity that I had hoped to do, but we just ran out of time, so we didn't end up doing it. This was a lens lab where basically you manipulated the object distance, changed where the object was relative to the lens, and then saw where the image distance was in response to that. So you manipulated DO, responding to that was DI. And then the graph that was plotted was, look at this, the reciprocal of the object distance, which is 1 over DO, and the reciprocal of the image distance, which was 1 over DI. Now, what do we ask for? Doesn't really matter. Okay, you can see that on in your handout what we're asked for, but don't even look at that right now. Just look at the graph right now. We know that we want the slope of the graph and the y-intercept of the graph. Okay, we know we're going to analyze the graph in that way because that's what we do. There is a y-intercept here, right? You draw that line of best fit. Don't worry about drawing that right now, but if you did, there's clearly a y-intercept there. Okay, how do you do it? Well, let's go through that process first of figuring out what the y-intercept and the slope are, and then we'll go through the process of actually figuring out what the values are. So, once again, from the graph, we've got y equals mx plus b. It's a straight line that goes down like this instead of up like this. That doesn't matter. It's still a straight line. The y variable is 1 over di. Not di, but 1 over di. M is the slope. The x variable is 1 over do. And you know what? Usually we kind of wait to put the y-intercept in there until we see the other equation has a y-intercept, but clearly there's going to be a y-intercept in this one. So we'll just put it in now. What equation from our data sheet has 1 over di and 1 over do in it? You guys know this? Come on. Yeah, 1 over f. 1 over f is equal to 1 over do plus 1 over di. Now, this is when, Daniel, I really want to change the order of this to match up. Okay? It doesn't matter on the right-hand side if it's quite the same order, but you got to solve for the same variable. In the first equation, I'm solving for 1 over di, all right? Usually it's in the form of 1 over f, right? But I want to rearrange that to take the form of 1 over di. So I've got the same variable that's equal to something else. So that means 1 over di is equal to 1 over f minus 1 over do. You know what? If I want to change it, Daniel, to the same order that's here, it's actually going to be negative 1 over do plus 1 over f, right? But that's not critical. It just helps me personally a little bit. Negative 1 over do plus 1 over f. Okay. Okay, let's cross off things that appear in both. 1 over di appears in both. 1 over do appears in both. What are we left with? Well, the slope is equal to negative? What? The slope is equal to negative 1. We know what the slope is. If you plotted this graph, the slope will always be negative 1. Or at least theoretically it should be. It might be 0.99 or something like that, right? But it's supposed to theoretically be negative 1. So you're probably not going to have to calculate the slope for this one since it's always going to be that value. Now, what's interesting about this one is the y-intercept. The y-intercept is equal to 1 over f. That's what you were going to do in the lab that we were going to do, is determine what the focal length was. You were going to get the y-intercept, not the slope, because it was going to equal 1. You were going to get the y-intercept, flip it over, and that would give you the focal length of that lens. Look at that. We've just analyzed it. We don't even know what we're asked for yet, but we've just analyzed this graph. Now this should be easy down here. Oh, it does ask us for the slope. Okay, let's not assume that it's 1. Okay, it should work out to be real close to 1, but let's figure it out just in case. But that's easy because all we have to do is punch our numbers into the calculator to see what the slope is, right? And then it says using the Y-intercept, what's the experimental value for the focal length? All right, perfect. Okay, this is easy. All we have to do is punch this into our calculator, get the value for the slope that it spits out, and then get the value for the Y-intercept, flip it over, and that's going to give us the focal length. So let's do that now. The bad news is you don't actually have a data table. So you're going to have to put your data in here from the graph itself. That's the one kind of pain in the butt thing with this. Okay, let's go into stat. Now I'm going to have some data in here now that I'm going to want to delete. Okay, you are as well. But again, on your diploma exam, this should disappear because your calculator will be cleared. Let's go over here. Let's put our data points in now. Our first data point appears to be 0.65, okay, on the x-axis. 0.65 on the x-axis. The second one appears to be 0.85. Okay, if you went down to the x-axis there, it's 0.85. The third one is right on 1.0. The fourth one is 1.15. And the fifth one is 2. As much as it's kind of a pain in the butt to take it from the graph, it's not all that hard, right? It's not like these are hard numbers to see what they are. It's pretty clear what the values are. All right, let's get the y values now. This one's going to be, notice on the y-axis, they're going up by 0.2 each block. So the first one is going to be 3.2. Second one is going to be, looks like 3.1. Third one is going to be exactly 3. Fourth one is going to be 2.6. And the fifth one is going to be exactly 2. Got my data. Then what do we do with it? Okay, you can have page 11 in front of you right now if you want. Stat, go over here to calc, go down here to option 4, which is linear regression, press enter again. Look at that. We said my slope was going to be, should be -1. What did it work out to be? -0.9. Pretty close, right? So we're going to say A is, or the slope is negative, what was it? 0.925. We'll worry about expressing that in a minute. The y-intercept B was 3.8255. Okay, let's take this 3.8255 and get the focal length from that by flipping it over. The way to do that is just to say 3.8255, x to the minus 1. Excuse me. Hold on for 1 sec. 0.2614. 0.2614 meters. Guys, hold on for 1 second, please. Okay, let's express this now. The slope of the line is negative a decimal b. Okay, so the slope of the line would be 0.9, right? 0.9. Make sense? And then what's the focal length? Oh, they want it in centimeters here. We've got meters, so it would be 26 centimeters or 0.926. Can you guys answer that question? Can you guys get that if that's on the diploma exam? I'm gonna be honest with you guys. In all the diploma exam questions on the graphing ones, since they started putting that on there that I've seen, I believe this is the hardest one. Okay, that doesn't mean you won't get a harder one, because something's got to be the hardest, right? And sometimes the hardest one is replaced with a harder one. But if you can do this, if you understand what we've gone through here, and with the other questions, you should be okay on that question. You will get one of these questions on the exam. You will. And you will get one of those questions that we talked about yesterday as well. And you'll get 48 other questions. Good?